Okay, so if you remember from last time, let me open up my terminal here. I had a chat server running. So this guy's just sitting there listening, waiting for a connection to come in. Then I'm going to go ahead and I'm going to use a built-in program to, and it's listening specifically on port 2222 on this machine. So we're looking at like network programming. So I'm going to telnet to the same computer localhost on port 2222. It's going to connect to that server. This guy is going to notice that a connection has now been established. It's asking me for my name. I'll type it in. So I'm reading in from this local thing here through telnet. And it sent it now to the server, and then telnet disconnected because the server ended. Server proved that it was able to read that in, and then it ended. All right. So the homework assignment was to replace this, what we're doing here for the client side using a built-in application telnet, write our own Java client that knows how to talk to our Java server. Okay. So let's go ahead and write that. So what we're accomplishing here, just draw a quick picture of the network because we're going to need to expand on this today as we go through here. So we have our chat server that's running here. And originally we used telnet to connect with this guy. And then the initial connection, we first established our connection. Let's call that connect. Then the server asked our name. And then the client wrote back. So I maybe replied with Mike. All right, so that was the back and forth cadence that we were doing for this, because we do need to make sure that we're reading and writing in kind of the correct order when the other guy, if both of them are waiting for them to write to each other, then they're just going to sit there in, you know, in perpetuity, because we're not going to make any progress if they're just both sitting there reading and reading blocks. We won't get anywhere. So what we want to do is we want to replace this telnet with our chat client. All right, so we're going to write our own program that mimics what that server did. Okay, so let's go and write this. We were using VS Code. There's my chat server. Okay, so I'm going to go ahead and I'm going to create a new file. We're going to call this guy chat client.java. And then we'll put it in the downloads folder for right now. Okay, so here's our chat client. Okay, so what you needed to do to figure this out is you needed to use the Java documentation. Hopefully you started off using documentation and didn't just go and find a chunk of code that connects if you found a chunk of code that connects and then you just at least reverse engineered it and made sure you understood the documentation, I suppose that's okay. But I would say that the first thing is I know I need to establish a network connection. So the way to do that is I need to establish a socket connection. So I'm just going to do a search here for Java socket. Should bring up the documentation for this dude. So here's the class for socket. Look at my list of constructors. Notice here that we have a zillion different ways of opening up a socket. The one that we're going to be interested here is this guy right here. Socket that takes in a string that's our host name, and then a port. Our port is 2222. Okay. And this guy lives inside of java.net, probably java.net.socket. Go ahead and yep, and imported it for me. And my host name is localhost. You could have also put 127.0.0.1 or the IP address of this actual machine. And I'm connecting on port 2222. Okay. My guess is this guy probably throws an exception when it's trying to establish a. No, it actually doesn't. Okay, well, we'll wait for it to scream at us and then we'll. Nailed it. All right. Remember, again, this is bad programming practice when we just say, I'm not going to deal with the exceptions anyway. So I just tell main to go ahead and throw the exception. That way I don't have to have a bunch of try catches in here. Not great programming practice, but it'll let us focus on the actual parts that are the network programming here. And I'm too lazy to write try catches. That's the thing. Okay, so presumably this we're not going to get. Won't get here until the line above connects. So we would say that this guy blocks. So a lot of the stuff we're going to be dealing with here, just like we were before, is with things that block and what if we need to do something asynchronously. And then we're also going to look at thread synchronization. Similar to some of you kind of, if we're moving forward, thinking about where we're going with this, we're going to start talking about threads today. And then we're going to talk about kind of the equivalent of that critical section that we looked at for what semaphores protect. Where in our case here, the critical section is going to be maybe a function that all the threads are sharing. Well, if you need to protect a single function so that 30 threads don't try to call that function at the same time, you need to have some way of protecting that. What's the kind of the equivalent of a semaphore for a function? So we'll look at things like that. All right, so here is our socket connection. Dump that here. So now what we want to do is from the client side, after I've connected, so this is that first thing we're going to connect, I then need to be able to read from the server. So to read in from the server, I'm going to use a scanner, but specifically I need to use the scanner around an input stream. And we're going to go look at our socket documentation here. And we're going to see that we have a get input stream function. So I'm going to go ahead and say scanner client input is equal to a new scanner built around s dot get input stream. So that's going to build our scanner around the input stream associated with the socket so we can read in from that. And we can actually go ahead and test this. So let's just say string question is equal to client input dot, what is it, next line? All right, so just to test the initial connection. So remember, you're going to start your server first, then we're going to start our client program in a separate tab. It could be in a different computer too. You just wouldn't say localhost here. You'd say the IP address of this guy. In fact, we can even test that here in a second. So I'll go ahead and go out to my terminal here, and I'll go ahead and just run my chat server again. So it's listening for my connection. I haven't changed my chat server at all. He's still behaving the way he behaved before. But now I'm going to come in here and I'm going to compile my chat client. All right, then I'll go ahead and run my chat client. And we see that it successfully connected and read in. And let's see here. So just to test this, what am I on Wi-Fi wise? I'm on, anybody else in here on CUWCS? Okay, well, let's see. I don't think it's going to bridge. I was going to have you just connect to, somebody else could connect to it to show my IP address, because here's my IP address. If somebody else was on CUWCS. Huh? Okay. So, so anybody who's typed in my code for chat client, let me start my server up again. Well, here, don't connect until after I've started my server. Change the IP address. Instead of localhost, put in this 192.168. Yeah, the same thing that says right now. It's right now it says localhost in a string. So 192.168.222.152. So that's going to be the IP address. I think that should be able to work connecting to it as a string. But don't connect yet, and only one of you should connect. Well, it doesn't matter. One of you is going to win and connect first. So make sure you recompile your client. I'll go ahead and get my chat server running. So now one of you should be able to connect with your client. Client compile and everything. Okay, there's connection established. So somebody, there, Emily, responded back. And that's because she's already running the client. She must have wrote for class, because my client doesn't have the ability to write back yet. But so we just saw network programming, right? Not on the same machine, somebody else's computer running a program running on a different computer. Okay, so we read something in. We're going to go ahead and just spit out what we read into the user. Now we need to read something from the user locally. So we're going to need another scanner to read in from the user. So we're going to say scanner local input is equal to a new scanner around system.in. So this is going to give us the ability to read from the local keyboard. All right, now we also need a way now of writing out to the socket, right? So we're going to have, what do we use, a print writer? Print stream. That's what system.out was, as a print stream. So we'll say print stream. Let's call this client output is equal to a new print stream, and print streams can be built with an output stream. So the output stream we're going to say is s.get output stream. So now we have the ability to write something out to the client. So we're using the sockets input stream and output stream to build local objects that know how to read from and write to. And we'll go ahead and say client output dot println local input dot next line. Okay. And this guy blocks, so that that little code there won't finish until locally we've actually typed something in and pressed enter. And that's when we'll actually send it over our client output. So a lot of stuff is blocking and things like that here. So I'll come back out here. I'll run my server again. I'll compile my chat client. Oh, I need to do java.io for my print stream. And I'll run my client. What's my name? That guy's done. And my client there connected. All right. So that's, I think, answer to the homework. Reasonable enough. All right. So as we go farther into this, we're probably going to want to start getting this code up on GitHub. So hopefully all of you have worked with GitHub at some point. What I'm going to do here is I'll go into my downloads folder. And I'm just going to create a new folder in here. CS450. Let's call this just chat. And then I'm going to put my chat client.java and my chat server.java. And I'll put my run chat server in here. And actually, I'm going to create folders in here, one for the server. So we'll put run chat server in there, and we'll put our chat server in there. I'll create another folder called client. Put my chat client in there. All right, so I'm going to go ahead and move into that directory. I'll just copy the run chat server to the client thing here. And I'll move run chat server to run chat client. And I'll edit it real quick. Okay, so I should still have everything running. I just have it inside of this folder structure now. So I can do my run chat server here. CD CSC450. And I should do my run chat client. What's my name? Mike. So everything ran on the server. Okay, so right now I have both my client and my server living in their own little directories inside of a larger directory with my automatic run scripts. So what I want to do is I want to go ahead and put that up on GitHub. So my view, the easiest way to do that anymore is using Git Desktop. If you have other ways of using GitHub or you have your VS Code already connected to it, that's fine. You do whatever you want. But if you do GitHub desktop, so I think it's desktop.github.com. Yeah. So desktop.github.com. Just go ahead and download that client if you don't already have it. Make sure you create a GitHub account using your Concordia email. Because if you create that with an edu email, they'll let you create private repositories for free. Once you have that, go ahead and open up Git Desktop. You'll have something that looks like this. Very first time you open this up, you'll need to go to Get Desktop, go to Preferences, and you'll need to sign in with your account you created. So make sure you've done that. All right, so once you've done that, just go to File, New Repository. And we're going to choose a repository name. So we're going to call this guy CSC450 _ chat. So I'm going to go ahead and put this inside of, I already have a folder on here called repos. So I'm actually going to just replace my large folder. So I'll put this into my repos folder here. Make sure you don't need to do a README here. We won't need any git ignore for this guy. So just say create repository. So we have that guy. So what that just did is it created the CSC450 chat folder here inside of my repos folder. Now, if you go into this folder, you don't see anything, but if I show all the files, we actually see there's some special hidden files that GitHub manages our repository with. But what I want to do is I want to move my client and server directories that I just created. I want to move them inside of this. So I'll move, what is it, dot, where am I at there? So I'll move server here. I'll move client here. Now I should have both of those dudes sitting in that folder with all the stuff that's still in them. Now you see that those two folders are gone from my original folder I created. So just get rid of that folder. And just to make sure we are convinced everything's still working, I'll go into repos, 450 chat. I'll go into server in here, run our chat server. Go into client here, we'll run our chat client. Type it in, everything's still working. So now I have all my stuff inside of my GitHub repository. So I have a folder that has that's been set up as a repository. I've put my stuff that I want in there. If I go back into Get Desktop here, I see a bunch of crap has changed. So I want to go to summary. I'll say initial commit, whatever, call it whatever you want. I'll say commit to main. What that does is it commits those changes locally to the local Git repository. Nothing's up in the cloud yet. Next, I'll go and say publish repository. And this is the important part. You want to do this the very first time you do this. Make sure you uncheck the keep the code private button, because if you do that, I won't be able to see it. And if I did that here, you won't be able to see my code without setting somebody up as a collaborator. But for what we're doing here, uncheck that and everything will be good. Then just say publish repository. It's going to upload that guy to the cloud. So now if I go to github.com. Here's my 450 chat. So here's the code we just uploaded. Here's our server. Here's the client we wrote in class today. So now you have all that code. So now I can just take that GitHub link and paste it in Slack. So now you have my full server and client up on Slack. So if you haven't done GitHub in a while, go back, watch the video, slow it down, do pauses in between what I just did. But hopefully all of you have used GitHub at some point in time, or just do a tutorial online for doing all that. All right, but now I have a convenient way of sharing all the code with you and making sure any updates we make in class, I can just make the change because they'll all be in this repository. All right, so next thing we want to do. Well, first of all, any questions about what we've done so far? Okay. Well, so if ultimately we want to have the ability for a bunch of individual people to have a chat conversation, that means we need to have multiple incoming connections, right? Well, so we can update our server to have 2 client connections. We could just create after he has 1 client connect, we'll just establish the server socket again and wait for another client to connect. Okay, now we support 2. Well, what if we want 3? What if we want 4? What if we want 5? And we have no control. I think I used the analogy a couple classes ago. Like, for instance, when you go and search on Google, you wouldn't want to wait in line for you to be able to put your search in. You want it to just happen. All right, so we're going to be reliant on threads here so that code, is this VS Code? Really, it comes down to this line right here. We want that line when an incoming connection happens and we pick it up, we want it to immediately, we don't want all this stuff to happen here in the main thread, because while all this other stuff is happening, another client can't connect. Make sense? So even if I put all this in a infinite loop and I just said, okay, we're going to do this crap forever. Okay. Now a couple of you had my my IP address here, but actually I don't even need to worry about that. I can fake it on this computer. So I'm gonna go out here. And I'll go ahead and run my server. So server's now listening, and he's capable of handling an infinite number of connections now. But he's gonna let one connection come in. He'll deal with that connection in its entirety before finally looping back around and allowing another connection to come in. And we'll actually probably be able to prove a timeout. There's probably some default timeout on okay. So I'm going to go ahead and say run my chat client here. So the first client has connected. Now, right now, that client and my server are both talking, but they're waiting on each other, right? So right now, the server is waiting for my client to reply. At that same point in time, I'm going to go ahead and try to have another client connect. And he's not able to connect yet. He's trying to connect on port 2222. I'll go ahead and say Mike here. Now this client will end. He's finished doing all the stuff he's going to do. Do we have a timeout? He finally did timeout. Have to do it faster. What did that guy end up dying. Probably needed to close our socket connection. Server running again. My chat client running again. Make it happen a little quicker. So it's next line that's not able to read anything from there. All happening on the same thread. I was hoping to have two clients connect. This isn't the way we're going to do it anyways. We're going to use threads, but I at least wanted to show, well, I can show it at the top level at the very least. I'm sure we could figure out how to make next line pause. But at the very least, we see that while this client is connected, this client can't also connect. It's waiting. It can't get to the server until the server has finished with this guy. And then next line is dying because it was trying to read from something that didn't have anything written on it. Do you have a question? Oh, you're just stretching. Okay. So what we really want to have happen is when we have this connection coming in, we want to pick up the phone, spin up a thread, hand him that socket, say, you deal with this guy. I'm going to come back here and listen for more incoming connections. So if we're going to draw a picture for that, we're going to have a thread that's going to do all those things. And I'll get rid of this here. So we'll have threads that will deal with the different chat clients. So we'll call this guy chat client 1, chat client 2. And what the chat server does is he spins up threads. And all he does listens for a connection and hands the live connection to a thread. So that's what that dude is going to do. All right. So in order to do that, we need to go and write some threads. So I think probably this class, you did some threads in Java in what, maybe the 250 class at some point in a few minutes, but at some point you've seen threads in Java. This would have been when we had the discussion about interfaces and talking about the runnable interface. So if we go into, we'll just say Java thread, and we see that there's a thread class in Java, and threads implement an interface called runnable. And all that interface says is you have to have a function called run. That's it. That's all that says. So we don't have to worry about, we don't need to worry about that. They're giving an example of how you might use thread. This is what we're going to do in ours. But to build a new thread by default, you use this constructor, but we're going to have our own constructor because we're going to build an object that is a thread. And then the magic function we have in our method summary is a function called start. So here's start. So this does the this thread to begin execution. The Java virtual machine calls the run method of this thread. So that's why it implements runnable. So anything we want the thread to do, we throw into that run method, but we actually call the thread start method, which does the magic of spinning up a thread and then calls run on that thread. That's what's happening behind the scenes. So that's why it's important that we make this guy a thread and then call start, rather than just make our own class that implements runnable and just write a run method and think everything's cool. It's not going to do that magical a thread is running thing. All right, so what we want to do is we want to create a little worker bee. So in our picture here, we're going to call this guy maybe a chat worker. Okay. And actually, let's keep the word thread on there too. Chat worker thread. All right. So we're going to go ahead and go to our code. I'm going to reopen this file just so we have it. Actually, I can just open a folder, right? Won't that make life easier? Open folder, downloads, repos, 450 chat. Yes, I trust the authors. All right, so we have our server here. We have our client here. Oh, we'll just have to flip between them. So for our, it's going to be actually the server folder where we're going to put our chat worker threads. So we're going to create a new file in here called chat. I'm going to start capitalizing. Chat worker thread.java. All right, so here's our public class chat worker thread. We want to make sure that we say this guy extends thread. So he is one of those dudes. He's going to be a thread. And because we're telling him to extend thread, we know that we're going to have a public void run function in here. This is what the thread does. Okay, now just like any other class, this is a thread, but he's a special kind of thread. He's a thread we invented. A default thread doesn't take it. We saw the constructor here. Here's a default thread. And constructors for threads take in no parameters. These other ones are dealing with like pre-populating threads, a little bit more advanced use of threads. For us right now, we're going to say a default thread is a thread that is created with no parameters and does nothing, but it's a thread. It technically is a running thread that immediately dies if you called start. Because when you call start, it calls run, run does nothing, so it just dies. That's its purpose in life. So in any case, we want our threads to be a little bit more talented than that. So what we want to do is we want to teach our thread. So we're going to have a chat worker. It's got public. I'll start off with no parameters in my constructor. So we want our chat worker thread. When we build one of these guys, we need him to do a little bit more. Now, specifically, what do we want this chat worker thread to do? If we go back to our picture here, when a chat server gets that incoming connection, he's sitting here waiting by the phone, right? Phone rings, he picks up the connection. Now, he wants there to be a chat worker thread that goes and deals with this guy. What is this guy? What kind of animal is this guy? When that accept method returns and that phone rings and that connection is established, what kind of objects is this connection? It's a socket. Okay, so if I look at my chat server here, this is the result of that thing. So that whole, that's like a walkie-talkie, that whole communication channel to that client is a socket. So if I can build my worker thread, to take in a socket connection, then we can set that field just like we set any other field in objects. Now, when I build a chat worker thread, I can say, chat worker thread, here's the socket you're going to need to do your thing. And then I'll tell them to go. So what we're going to need here is we're going to have our logic inside of run handle all this extra stuff that this guy is going to do. So out here in our server, we're going to go ahead and we're going to create a chat worker thread. T is equal to a new chat worker thread, passing it my client, because that's the name of the socket that was just created. Now, all this other stuff here, I'm just going to cut it out of there for right now. Now we're going to say t.start. So we'll create a thread and we'll tell that thread to start. So what's going to happen with that thread is it's going to start doing everything that's inside of that run method when we tell it to start. So I'll go back over to my chat worker thread. And just for the moment, I'll just paste all that stuff in, even though I have some wrong variable names and stuff, into run, because that's what I really want run to do. Now I can move a couple of these things around. I don't have to spit out that a connection was established, but I'll go ahead and do that. Actually, let's just do that very first thing. So when this constructor is called, I'll spit out a connection's been established. All right, now I'm going to start building some things. So for instance, I know I'm going to need a print stream. So I'll go ahead and create my print stream. Import java.io. So in my constructor here, I'll go ahead and I'm initializing this thread. So I'll go ahead and set my client output, which is a print stream, equal to a new print stream built using my client socket, get output stream. All right, so now again, this guy could throw an exception, unhandled exception. If I chose to do, and I can set this. There we go. So I can choose to say, oh, well, I'm just going to have this guy throw an exception. I can do that one, throws exception. But if I do that, now my error is going to be back in my server, because this guy, oh, he already throws an exception. So technically I don't have an error right now. But if this guy didn't throw an exception, all my thread did is it said, server, you created me, deal. It just throws it. And then the server is just going to pitch it as well. So you create this daisy chain of not taking responsibility for problems. At some point, you probably do want to have some try catches just so you localize your issues. Okay. So I'm going to still say throws exception here for things that happen specifically here in Maine. That's that server socket thing that's going down here. But I'm going to go ahead and inside of my chat worker thread, I'm not going to just pass the buck. I'll handle this stuff inside my constructor. I'll go ahead and just try to do all this stuff. What was this? Give me like a, oh, look at that. Snippets. That's why people like using VS Code, I guess. Except I don't like the curly braces. That's a bad curly brace situation. Okay. So I'll try to do all this crap. So I'll set the client socket, even though that doesn't technically need to be tried. Then I'll set my client output equal to a new print stream built out of the output stream of that client socket. In my catch, I'll say system.err.println. That's using standard error instead of standard output. Some clients will make that show up as, or some terminals will have that show up in red text as, you know, showing an error has happened, but it's just an error. Bad things happened in thread. And if I wanted to, I could do e.print stack trace. That'll give me the full error message or whatever. I'm interested in seeing that. Okay, so now we need to build out the rest of the pieces here that we need. So we have our client output. Now we need our client input. So we're gonna need a scanner. So private scanner, client input. And scanner is in java.util. It's just going to be easier for me to just import java.util. What'd you do? I'll say this dot client input is equal to a new scanner built out of my client socket. Get input stream. And I like using the this keyword, even though it's not required in these places. So that's my setup in my chat worker thread. We'll spit out connection was established. We probably, well, this will spit out just to the local terminal. So actually, if you have 10 threads, they'll all be printing out to the same terminal like we saw with our, when we had child processes with the fork system call. If we did printouts, printfs from those guys, they all showed up in the same place. Then we went ahead and created our client socket, or set our client socket. We got our output print stream and we got our input scanner. So we did all our initialization here inside of our constructor for our chat worker thread. And then when somebody else calls start, this is the stuff that's going to happen. So we're going to write out to the client, what's your name? We'll read in the name from the client and we'll print out that we read something. Then the thread's going to die. We look at our method summary here. Let's see if we have a appropriate way of killing a thread. Or does it just die when it? Oh, that's fun. So this destroy method, they deprecated it. The rationale was it was originally supposed to be there to destroy the thread and clean it up, but they never actually wrote it. so, so it's like, well, they didn't implement it, so we're just gonna kind of just let's get rid of that because we have no intention of like I think this is probably like a thing about that saying that they never wrote the stuff. Doesn't matter.
Is that something about stop causing like some sort when you're looking at stop earlier, like earlier it had stop up there and it was saying something about like it causing an issue or something.
This method is inherently unsafe. Part of that's going to be because the operating system is sharing CPU time. One, you may have seen a word before if you've been looking at any documentation called, is this, that such and such is thread safe? A lot of times that's with collections, like linked lists, stuff like that, because you have multiple threads that might be using that same resource. So this comes back to how that operating system is schedules threads, because threads actually share the CPU time of the parent that spawned that thread. So let's see, this method is inherently unsafe. Stopping a thread with thread.stop causes it to unlock all of the monitors that it has locked. It's a natural consequence of the unchecked thread death exception propagating on the stack. If any of the objects previously protected by these monitors were in inconsistent state, the damaged objects become visible to other threads, potentially resulting in arbitrary behavior, i.e. not thread safe. Many uses of stop should be replaced by code that simply modifies some variables to indicate that the target thread should stop running. So effectively just let our run method end. Yeah, interesting. Seems like they did implement that one though. All right, so we'll just go ahead and run method will just naturally end. So this is what a thread, a chat worker thread does. When we create him, he sets up our IO stuff with the socket. And then when he starts, he talks to the client based on the socket that was handed to that thread. So now inside of our server, we'll have our server socket. We only need to create that guy once. Then we'll say while true, we'll print out listening for connection. We'll accept an incoming connection. As soon as that connection comes in, we'll build a chat worker thread with that socket, and then we'll tell that thread to start. We tactically didn't need this variable here. We could have just passed s.accept inside here since that blocks, but this will do it. So as soon as we say thread start, the server can spin back up and start listening again for another incoming connection. All right, let's go test this dude. So here's our server. So our chat server is sitting there waiting for the first connection. We'll go ahead and establish a connection here. We'll establish a connection here. Notice that both of these guys are now connected. So both of these guys are talking to two separate threads that are handling their communication, and our server should be listening again. Listening for connection, connection established. Listening for connection, connection established. Now he's listening for another connection. Go ahead. Absolutely. So if any of you who had my IP address, go ahead and you can try to join. No harm, no foul. And I don't have to change any of my servers, just sitting there, he'll spawn off threads all day long. So I'll type something in there. Now that thread died. Now the server, it's printing out red mic here, but the reason it's doing that is over here in my chat worker thread. I'm saying system.out.println red. The threads exist on this computer, so they're all writing out to the same monitor. So it wasn't my server main that printed out. It was this thread that printed out. It just happened to be that I have two threads sharing one monitor. So a system.out.println to this monitor will show up in the monitor regardless of the that it's a different thread. I can go back here, type in Dave. Read something there. Nobody else is connected, but I can go and reconnect with one of these. So he's talking to me again. There's Jeff. And he's still listening for a connection. Go ahead.
How would you have the server like print out when it was like a new connection?
He's already doing it. Connection established.
Oh,
But actually the person who's writing that is the thread. So you can either do the system.out inside of the server main before you create your thread, or you can just, I have it inside of my constructor for my thread. So right here, when I build a thread, I have him go ahead and spit out saying a connection has been established because, you know, boss man just told me to go to work. So that's what's going on with that. All right, make some sense? All right, so threads, no big deal. We're able to have a whole bunch of things connect, and we can just keep having things connect. And, my server's just still listening. If I want to kill the server, I can hit Control C over here. That'll kill it. That's what you do on Unix. I'm guessing that probably works on Windows as well. And Control C will probably kill stuff. Okay, questions about that? All right, so what do we need to have happen next? And just so you have the current up-to-date version of the code, I'll go ahead and say updated for server threads. Commit the name, remain, and I'll push to origin. So now the code up in the cloud is up to date. Go back to our picture here. The purpose of a chat server is for our clients to chat with each other, right? Right now, anything that a client spits back is heading out to the screen on the server. Well, that doesn't let client 1 and client 2 talk to each other, right? We're not fulfilling the job of a chat server. So how would you implement having multiple connected clients being able to type stuff and see what each other types? It's going to be the first part of your homework for Thursday, so we might as well brainstorm this. It's not actually bad. Well, what has to happen? How does this chat worker thread, who's receiving a string from this guy, and this chat worker thread, who's receiving a string from this guy, how did they let each other know about the strings that they received? Effectively, we're solving the same problem as we talked about before of how do we share process IDs between processes. Except now we have local memory since all the threads live underneath the same source thread. Go ahead. Oh, you didn't have a question? Okay. So let's go down that path. How would they know about each other? How can we make all of our threads know about each other? Oh, I thought this was uncomfortable. Why is my chair way back there? Garbage. I'm going to throw this out the window when we're done. Go ahead.
Do they already know about each other?
Well, I guess potentially, with the problem being that what does the parent do with the thread? After he creates a thread, he just moves on with life and he overwrites that variable the next time around. So he's not really keeping track of his threads. Yeah, you can create an array list or something of threads. That would be handy. So, we can do something like array list. Call this guy the threads, and this is going to be an array list of chat worker threads. And then in here, every single time we create a thread, we can just go ahead and say the threads dot add t. So we'll just toss our threads onto our array list of threads. Not sure what we're going to do with them yet, but we have them. So the parent has this big collection of threads now. Go look at the documentation and say, okay, well, what can threads do? Yeah, that's going to return. I think in current thread probably gives a current executing thread object. So this is going to give whatever one that is actually getting CPU time would be my guess. But we have all the threads now. I mean, in our array list, we have a collection of all threads. Go ahead.
There's something in the platform like get active thread or something.
Mm-hmm.
It seems like that gave
We already have all the threads. Yeah. So that might be true. There might be a way that maybe the parent collects the threads that are under it, that's under it, even if they you didn't purposely store them, but we did purposely store them. So any way you cut it, we have the threads. So you can interrupt threads. So here's our join. Join is similar to what we did with wait in C. So join says wait for a specific thread to die. We can also join and wait a specific number of milliseconds. Set the name, set the priority, tell a thread to go to sleep from some period of time. We can tell a thread to yield. Maybe it's a low priority thread. So when you say yield, it says it's a hint to the scheduler. The scheduler would be the operating system component that is deciding how the threads get scheduled on the CPU. So if a thread is doing something that's not overly important, they might say, hey, look, I'm willing to yield. I'm doing background stuff. So if something more important than me needs a CPU, go ahead and give it time. Okay, so that's what threads can do. None of that really says much about how do we make threads talk to each other. Because ultimately, what do we want to have accomplished here? In our example, what did I write out here? I wrote out Mike, Dave, and Jeff. So let's just use the Mike and Dave. I want in this picture, if this is Mike and this is Dave, I want Mike to see the string Dave, and I want Dave to see the string Mike. How does this guy receive the information? How can this guy receive stuff from this guy? What's required? What is required for this guy to get any information? The socket, right? All communication happens with an input and output stream. So one way or another, this guy is going to have to either get direct access to this guy's output stream or get indirect access to this guy's output stream, maybe from the thread. So maybe the thread that's dealing with it collects the values that are coming in, and then the other threads can go and check on that. Or maybe a thread, when he receives something from his client, he then distributes it to all the other threads. Go ahead.
Generally speaking, do you just have the servers exclusively for free?
They can do whatever you want. Right now, our server only creates threads.
The server can establish the socket for all of them.
Yeah, except right now, the server's pretty busy just waiting for the phone to ring. But you could create another thread. You know, you can create maybe a, well, I mean, this is a decent idea. You can maybe create a, you know, I don't know, a chat manager thread. And the whole job of the chat manager thread is he sits there and operates off of some global list of threads and just sits there and makes sure that he can write out to those threads. He's a broadcaster, right? So anything that you send that dude to do, he just broadcasts out to the group. Could do something like that. So that's ultimately what we have to do, is no matter what these guys write, these guys have to somehow broadcast that back to all of the other threads, preferably not to the thread that wrote it. That way you're not getting your same crap back to the screen, but it's okay if you do. It's not the end of the world. No, I guess that's true. Use your name next to it. Yeah. So we have to have some sort of ID or whatever. Go ahead.
So what's the end goal? Are you trying to create something where it's one server, but there's multiple rooms with like 2 people in this room, 3 people in this
Well,
room?
maybe eventually. Right now, it's just a single general chat room that everybody dumps into the same room and they can type stuff and everybody else sees what they typed. That's the goal. So for our homework, let me get my current link. Given that dude allow all connected chat clients to see all messages sent from themselves and from other connected chat clients. i.e. make chat work. Make chat work. I'm debating whether I should give a hint. Well, here's the thing. If I give this hint, that would push everybody to solve it the same way, when I think there could be some interesting solutions to this without a hint. But there's no reason why you shouldn't be able to stumble upon the hint on your own anyways. So I think I won't give a hint. Well, only if there's evidence that you've been working on it and hit a roadblock. I guess maybe I would privately give a hint. But if we're sitting there at, 10 a.m. on Thursday, and it's like, I just opened up the homework. Do you have any suggestions on how we do this? It's not going to be that hard. It sounds harder than it is. And it's not going to be that much code. How about the last one was not that.
If you didn't know you need 2 main methods, is really difficult.
You have 2 programs.
Right, but when I think of that, I think of like 2 classes.
Well, right, but so once you understood the solution, then you realized it was easy, right? So I mean, just suck less this time, right? All right. I'll give you a one-word hint. Everybody remembers that word, right? Singleton design pattern. Remember when we talked about singletons and MVC, and design patterns would have been in 250. Okay. Questions, comments, concerns, bribes? What? I did already. Yeah. Oh, no, I didn't do that one. Added array of threads for no reason. LOL. Yeah, the array of threads is actually just going to confuse you because like, oh, I need to use these threads. Hint, hint, don't use the threads.
Oh,